Hi, this is a video about mlogfilter. You may have guessed it from the name. mlogfilter is a script that lets you filter MongoDB log files. It works on a line-by-line basis, and with options that you can specify, you can include or exclude certain lines in the file. One of the principles of mlogfilter is that its output is always, again, in log format. So you can pipe the results of mlogfilter to another script. It could be another instance of mlogfilter or mplot queries if you want to visualize the results, or even command line tools like grep. Speaking of which, of course, if you're familiar with awk, grep, or other command line tools to filter files, you can combine those with mlogfilter as well. You can pipe the result of one of them into another and combine them and eventually visualize the data or store it in a file. mlogfilter just offers some convenient options because it understands the structure of MongoDB logs. It knows where in the string certain operations are stored, and it knows about durations of operation and namespaces and so on. So feel free to mix and match and use whatever tools you like and combine them with mlogfilter. The first example I want to talk about is filtering by time. For that, I use mloginfo to get an overview of the log file that we have here. If you're not familiar with mloginfo yet, there's another video that describes how it works and what it can do. But just as a quick overview, it shows you some general information of a log file. I'm mostly interested in the start and the end time here. As you can see, the log file covers about 24 hours, from July 2nd, 6:45 AM to July 3rd, around the same time. mlogfilter offers two options for time slicing. It has --from and --to. Which let you adjust the sliders of your time window on the left and the right side, respectively. You can use either one. You can also combine them to limit both the left and the right side of the lines that you're interested in. So let's say, in this example, I want to see what happened on July 2nd around 9 AM. I can copy the format from mloginfo and just add 9 AM. And because that would output many lines, because this is a quite large file, over 1 million lines, and a lot happened after 9 AM, I'm just going to look at the first few lines. First 3. So I pipe it to head -3 and scroll up a little. And you can see the first line starts just after 9 AM, 400 milliseconds later. And then another one a second later, and another one here. mlogfilter is quite flexible in the format that you specify for both --from and --to. You saw me copy and paste the output of mloginfo before. I could also go ahead and copy and paste just one of the actual timestamps in the log file, for example. As long as you include a date, maybe the year, month, day, and some time in some reasonable format, mlogfilter usually understands it. There are also some keywords that mlogfilter understands. Let's say, rather than a specific point in time, I'm interested in what happens 2 hours after the start of the log file. This is useful, for example, if I roll over the log file at a certain time and then want to check what happened 1 hour after that. For this, mlogfilter uses the keyword start. And then I can specify a relative time. I can say from start plus 1 hour. You will also notice the quotes. And while they may not always be necessary, I recommend that if you use relative times with the plus or minus modifier, just wrap the entire value into quotes, especially with the minus, because it could be interpreted as another option. So if I'll do that, and again just look at the first 3 lines, then you see that it starts at 7:45, 1 hour after the actual log file started. These keywords work for both the --from and the --to. So I could also specify 2, and I could use end -1 hour. That would output everything up to 1 hour before the log file ends. If you use both --from and --to, there's another nice option that I want to show you. Let's say I want to slice out a window of exactly 1 hour, starting at 2 PM on July 2nd and going to 3 PM. I've already specified the start time in the from value, and I don't want to repeat everything here. So what I can do is just specify a relative value. If mlogfilter only finds a relative value in the to option, it will base it on the value from the from option. So in this case, we'll get a window from July 2nd, 2 PM to 3 PM. Let's see if that worked. First, I look at the first couple of lines, and you see here it started at 2 p.m. and now I repeat the command, but I look at the last 3 lines. It takes a bit longer because it has to go over this entire hour, and you see it finishes with 2:59:57, just before 3 p.m. Other fields that you can filter on are the namespace with -- namespace, and then the database dot the collection, the usual syntax. You can also specify an operation, and possible values are queries, inserts, updates, deletes, get more, or command. Here mlogfilter actually has an advantage over a simple grep. A grep would find the keyword update anywhere in the line, even if it was in the query itself or in the data somewhere. mlogfilter knows where to look at in the log file, and it knows where it says update. So it will only return lines where the update is right here after the connection. This is where MongoDB logs what kind of operation it outputs. Similarly, you can also search for a thread or a connection with the -- thread option. This is useful if you want to trace a single connection back and see only operations that happened on this connection. Oftentimes, you want to find out if certain operations were running slow, where the performance could be improved. mlogfilter also has an option to detect slow queries. You can use the -- slow option. The default is 1000 milliseconds, 1 second, but let's say I'm interested in all the operations that ran for at least 1 minute. I would specify 60,000, and you see a lot of output scrolling over the screen. And one of the things I notice here is that a lot of them are write-back-listen commands. And without going into too much detail here, the write-back-listen command is just part of the normal operation of sharded clusters. And you will also notice that they all take exactly 300 seconds. So those can safely be ignored. So let's filter those out. I can pipe the output of mlogfilter to a grep command using the -v option to exclude certain patterns, and then just remove all the write-back-listen commands. So this is an example how you can combine grep and mlogfilter. And now what we get is actual queries that ran for at least 60 seconds. And those are usually bad, and we'd like to find out why they took so long and how we can avoid that. So here's one example. You can see over 60 seconds, just over, but there are also other ones that are much slower. Here's one that went for over 300 seconds. So we have a collection scan here, no index, and you can see that this scan went over 28 million documents, and it also had to sort them in memory. That's what the scan and order field here says. It yielded over 10,000 times, 14,900 times. So if we see such lines in a file, we'd probably want to investigate what kind of index we could build to support such queries. And mlogfilter can help you find slow operations. A similar option to the -- slow is -- scan. Sometimes operations, even if they are scanning many documents, can be reasonably fast and wouldn't be caught by just limiting by duration. So I've built in another way of detecting such collection scans, or actually also index scans, because even scanning over large numbers of index entries can be inefficient. Let's see what the command does, and then I'll explain a bit more in detail how it works. So there's also lots of output. Let's look at some of these. This one here, for example, looks interesting. So as you can see, the command itself was quite fast, 185 milliseconds. So this wouldn't even show up in our slow query filter. But it still scanned over 10,000 documents here and didn't return any at all. It was an index scan, so there is an index that can support it, but it's not a very efficient query with 11,000 documents scanned. 2 conditions have to be met in order for -- scan to include a line in the result. N scanned has to be larger than 10,000, and the ratio between N scanned and N returned has to be larger than 100. In this case, because N returned is 0, I'm actually replacing it with a 1, so I don't have to divide by 0. These 2 conditions are quite arbitrary, but they have proven to, in many cases, work quite well and point out to queries that could either be optimized or that need an index, so they don't have to scan that many documents. So if you're chasing down some performance issues, try -- slow and -- scan with mlogfilter. mlogfilter has quite a few more options to filter out certain lines and events, and as with all the mtools scripts, you can get additional help with mlogfilter -- help. Some of the options don't actually specify filters, but do other things that I think are important and interesting to know about. For example, there's an option to invert the filter. If you specify any number of filters and then also add --exclude, mlogfilter will actually invert the filter and return all the non-matches instead. Another nice option that I find useful from time to time is --shorten. As you saw before, the log lines can be quite long and they wrap around in the shell and go over multiple lines, and it's hard to read. So with --shorten, you can actually limit the line length of each of the lines, and mlogfilter will cut out a piece in the middle to match that limit. So as you can see here, each of the lines has just 3 dots in the middle. That's the part that's taken out, and the beginning and the end is printed, and the limit is exactly 80 lines. So with this option, you can scroll through a file and each line is an actual log line, and sometimes you see pattern like here. All the operations take about 100 milliseconds, and if I go a bit further up, I get these really long operations here. And then I could look at those in more detail by just copying the timestamp from the beginning and making a time filter. Finally, mlogfilter also lets you merge log files. That's very useful if you want to look at a whole environment, if you have a replica set, if you have log files from an entire cluster, and you need to understand what happened across all these different nodes. So mlogfilter would take any number of log files and merges them by time. And it will also insert a little marker for each of the lines so you know from which file it came originally from. Let me demonstrate that for you. Here I have a log file of a primary, a secondary, and an arbiter. And of course you can apply all the other filters that we've gone through before as well. Let's have a look at a merged view of these files starting at 9 AM. And maybe just the first 10 lines. Here we go. I'm scrolling up a bit. And what you see is that this marker here indicates from what file the original line was from. There's another one from the primary. And they are ordered by time. So if I scroll down a bit, here we see one from the arbiter. And I can't see any from the secondary in that short window, but that would just also appear as secondary.log. And this way you can easily get an idea what happened across several nodes at the same time. And again, if you have any questions and want to see what other options are there for mlogfilter, just use mlogfilter-help and you get the usage and some explanation for all the different available options. And that concludes the mlogfilter demo.